So I think I'm next. I'm actually wearing two hats tonight because yes, I have a full-time job, which is not about volunteering for PE, and it's at Verity Tracking. It's a verified traceability solution. I've been working for about a year as lead Europe and head product. So I'm gonna start telling you a bit about Verity, but I also like to go to maybe a more practical case with some question and answers, where we look at, okay, if you take agricultural commodities and we want to track, carbon emissions and quantify carbon, how could we crack that case together? To start with, so Verity is a digital, not yet decentralized, but digital MRV tracking platform. We're collecting, verifying, and tokenizing sustainability claims. So now a sustainability claim could be a carbon credit, an offset, but it could also be a product, a footprint, or a product life cycle assessment. We're especially looking at carbon intensity scores in value chains that are difficult to measure because they may rely on biomass, like think about biofuels, biogas, biomethanes, and new types of energy that we need to support to shift away from fossil fuel. And talking about that, I wanted to show this because I've been crunching some numbers lately, and I was thinking about, for climate action, what are the real problems we need to address, right? And you hear a lot about, planting trees and reducing consumption of plastic straws and things like that. Yeah, it's really nice. But every hour, we are pumping 2.5 Olympic pools of oil from the ground, right? So this is something that's not going to stop. Maybe it's going to stop, but that's the rhythm we are at today. And basically what's happening is every time you take carbon that is sequestered in the soil for millions of years, you're putting it back in the cycle, right? You burn it, it goes in the atmosphere, you may plant trees, you may do carbon projects like carbon offsets, which maybe have a lifespan of 5, 10, maybe at best 100 years, but then they go back in the cycle, right? So we need to really focus on that and think about what are the big problems. And for the case of oil, it's about 34% of emissions globally. To give you an idea, the voluntary carbon market in 2022 was about 0.8% of that. And again, we're talking about things that last 5, 10, maybe 100 years and go back. So it's a little bit scary. So what do we do about gasoline and diesel, and car, trucks, aviation, maritime, asphalt, industries? And it's fun to talk about nature-based solutions. Yeah, it's really good, but I think the ReFi has also to focus on this issue. Right? So this is what Verity, we focus on things like agricultural commodities, biofuels, sustainable aviation fuel, marine fuels. And there's something on which the EU just released new methodologies or certification schemes for RFNBOs, which are renewable fuels of non-biological origins, like green hydrogen, ammonia, e-fuels, which are also kind of new energy types, which will help to move away from fossil fuel. All right, so now let me talk a bit about emission reduction and quantification. Here you see Microsoft pathway to carbon negative by 2030. And usually companies have a twofold strategy to go with that. They look at the blue part, which is their own emission and the emission in their supply chain. And then they look at carbon markets in the sense of offsets or carbon removals. So when we talk about MRV or DMRV with small or big D, whatever, and data tracking, I think it's really important in both perspectives. So it's not only a carbon market thing, it's also, and primarily for me, about understanding your emissions in your own activity and your own supply chain. And if you're familiar with that space, there's something called the SBTI, the Science-Based Target Initiatives, which gives kind of a framework for companies to follow a trajectory of net zero, in which you can actually not use offset to just simply continue to pollute and say, hey, I just bought a lot of offsets and now I'm clean. No, you need to have a reduction strategy in place with intermediate targets and net zero targets. They need to be aligned with the Paris Agreement. You can use temporarily offsets to neutralize your emissions, but then you need to rely on carbon removals. Right? So it's a little bit complex, but it's super interesting if you guys want to learn more. And so how are companies doing it? They would use something like the GHG protocol. which basically splits the emission in 3 buckets, the scope 1, 2, and 3. Most companies nowadays, they're doing the scope 1 and 2. The scope 3 is a little bit more difficult. So these are your direct emissions. This can be the energy that you consume. And this will be everything in your supply chain, basically. So that you don't control directly, but they fall outside your own system boundary, right? And scope 3 is, it's quite difficult. If you're a service company today, maybe 80% of your emissions are within scope 3, because you don't produce, you don't burn, but maybe you have people flying around or traveling to the client and things like this. And so the way you do the quantification, you do life cycle assessments. So again, you understand the system boundaries. You can do it at the level of the company. That's typically what you do for like ESG reportings. Or you can do it at the level of product. And I know there's some LCA product specialists in the room, like Suzanne and some others. So if I say anything wrong, please. But and basically you look at all types of GHG emissions and you convert them into CO2 equivalent. In our case, when we look at biofuels, it gives us a carbon intensity score. So it's an amount of gram of CO2 equivalent in, let's say, a quantity of product. Right? So you can have it in a bottle of shampoo or in a liter of biofuel. And so the platform we're building is basically that traceability, especially applied to SAF, sustainable aviation fuels, and biofuels in general, where we're collecting emissions at the feedstock level, whether it's first generation like bioethanol or waste-based fuel, it would be the same, but you look at different supply chain and possibly different data. The processing stage and then the transport and distribution until you have a full product footprint or product certificate. If you look at SAF, it's quite interesting because right now in the EU you have about 2% of the fuels of airlines, which is SAF, but the EU is mandating 63% by 2050, right? So it's a real takeoff, whereby actually the only way to reduce emissions from airlines nowadays is switching fuels. And you've been all offered the possibility to buy carbon offsets, right? When you buy tickets, that's something airlines are slowly going away from because they're actually looking at reducing their own emission in their own supply chain, right? So again, scope 3 and enabling their clients to do the same. There's also some of them have had controversies with the carbon offsets, right? It's lack of transparency and things like this. So for example, EasyJet just dropped their offset program and they'll focus on buying more SAF. And I believe they need a system like we're building to go basically from the feedstock, so the raw material of the fuel, and have an end-to-end traceability until a passenger seat, where we can quantify exactly the emissions of a passenger seat and allow, for example, a customer, a corporate customer to buy the GHG reduction from the SAF certificate as a way for them to reduce their scope 3 emissions. Right, so we see a lot of projects like this happening in logistics, in marine, in the flight industry, and what we're building is the full end-to-end traceability. It's also interesting for the airlines because then they can go backwards and they know exactly where the raw materials come from the fuel they're buying. So they can also make sure it's sustainable, it doesn't cause land use change and things like this. And that's a more complicated view, which I will save for you, but we're basically collecting data, hashing data, recording a number of data points for auditability and transparency on public blockchain and IPFS, and tokenizing both the commodity, which can be the corn and then the fuel, and also the GHG emission reduction, so how many tons of CO2 have been saved. And in some cases for the SAF, it can be 50%, but in some cases it can be 100%, and there are people ready to pay for that because it's going to basically reduce the emission baselines. So yeah, that was it for the first part. And now maybe we can just look at a case where the idea was to make it a little bit interactive and you guys can just give your ideas. I'm just here to facilitate. Is there any question before we move on to that part? Or okay, good. Okay, so let's think about your role as a producer of bioethanol or sustainable aviation fuel or this type of commodities. And let's say you have a facility, it could be anywhere in the world, and you're using corn from 100 plus growers for both food and fuel outputs. So nowadays you have a lot of companies that get proteins from a corn for the cattle industry, for example, and with the remainder of the plant, they will produce bioethanol. The goal is to track precisely emissions in the value chain, to reduce the carbon intensity of the feedstock, and then also introduce a premium so that you can reward the growers for switching to regenerative agriculture practices and basically reduce their footprint on climate. And so my first question is really open, but like basically, how do you think you would go about calculating the footprint of agricultural product? And we take the example of corn here, but it could be anything. It could be beef, could be any energy crops or anything. So how would you simply go about it? Any idea?
Look at the inputs, what's required to create it.
Yeah.
Whether that's fuel or things that need to be bought.
What would you think about? Like what inputs?
I mean, I'm imagining a tractor needs to get full or something.
Yeah.
You definitely know farm.
Yeah.
There's probably different techniques, I guess.
Land.
Say it again?
How much land?
Yeah, the land.
Water consumption?
Water. What else?
Vehicles used.
The vehicle, yeah. Let's say equipment.
Fertilizer.
Fertilizer. Yeah. What else?
Like changing the ecosystem?
Ecosystem impact, yeah. You have something specific around that, like?
No,
what?
like maybe, I don't know, like if you're like cutting down trees like that were native or what kind of impact it has to everything else that's going on.
So yeah, this is something that the industry refers to as land use change. There's also indirect land use change. Like if you say, hey, we're producing corn to make ethanol, so it's going to create indirect impact on another piece of land somewhere else, right? Which would be used for corn, for example. So this is also something we definitely need to take into account, especially when you think of energy crops, because indeed there's a question about risk for deforestation. Right?
Yes.
And obviously also competition to food markets, and there's a lot of controversies around that. But I believe this is why it's important to make sure they're sustainable.
Which is why my question is, when you say calculate the footprint, is it just, what is it? Because social footprints, not many are calculating exactly this displacement, for example, or food shortage. All these things need to count in this calculation.
Yes. So,
The farming practice as well, what do they do between crop seasons? Like do they burn the stubble, do they dig it up, do they plough it? There's a whole bunch of things they could do.
yeah, okay.
What data would we track? The soil.
Soil.
Health. Because I think soil has this nexus of water, biodiversity, carbon, so you can have, you have indirect indicators from which are mostly, you can infer the water quality, biodiversity from that.
Yes.
I would look at the counterfactual or the opportunity cost of not having some sort of other commodity production.
Yeah. Okay.
Satellite image and it's time-lapse.
Okay. Okay, we'll get to that. Okay, I'm trying to move ahead because looking at the time. So yeah, so basically one answer could be we can use a life cycle assessment model which tells you, hey, you need to collect all these inputs and then we give you the carbon intensity score. And the inputs could be about the yield, obviously, of the grain. It's funny that nobody talked about the yield. We talked about that, but basically the main contributor of carbon intensity is yield. Because if you have a low yield, then you divide the same amount of fertilizer in lower amount of yield, right? So we don't always think that way, but that's why it's important to manage performance, but also carbon intensity, yeah.
And I mean, that's the case if you specifically look at carbon and climate impacts. But you also then need to consider if you drain the soil, if you drain this field, it may not be able to produce over a long time period. to my knowledge, we don't have something to really measure this right now, but that's important to consider in respect of the youth as well.
It's all interconnected, definitely, yeah. So yeah, you look at these energy inputs, fertilizer, the soil organic carbon, yeah, you can measure a lot of things in the soil. Yeah, but
You can also measure the impact on like adjacent food systems. Like, I don't know, usually maybe you would use the corn for like, people to eat it, but now you use it for energy. This of course has like effects on like other food prices, or maybe people like consuming corn would eat more meat, like then you have negative footprint.
yeah, this is what people look at, especially in indirect land use change. So the reality in the US, for example, 98% of corn is for non-human food. It's for the cattle industry. Which you can also say, well, it's a little bit stupid, so what about we reduce meat consumption? Then we don't need all these lands. I'm not here to solve all these issues, but okay. But I just want to mention that there are a lot of companies, whether they're corporates or startups, that have other ways to go around it. One is getting rapeseed oil, right? Also for fuel or E10, ethanol, or things like that. They have a questionnaire to farmers twice a year, and if the farmer has a good score based on declarative data on questionnaire, they get 80 euros per ton of rapeseed that they deliver as a premium. And that's it, so no MRV. There's also ones that use the LCA model, but they don't really have the real data because they don't invest in the MRV and they don't do tracking. What they actually do is they use default values. So you don't have the data, it's fine, just use national average. And there's a lot of companies doing it, and they get the benefit from it from the government, and they get the product certified, but they don't really know what's behind. And there are no real rules on how much default values you can use or not. Then you have some that do purely satellite carbon stock estimation, which is interesting if you think about scaling. We had some questions about how do you scale it. If you use only satellite monitoring, yeah, maybe it's low cost and you can do it globally. Or then how do you look at, water irrigation, fertilizer use? There's a lot of emissions that are still very difficult to capture from space. And then there are many, and including traditional carbon credits as well, that are looking specifically at practices. And they say, if you stop tilling your farm and your field, we just pay you money, like 40 euros per acre per year. Right? And they don't look at the exact outcome, so they don't quantify carbon as such. Okay, where could carbon removal credits play a role? What do you think about carbon removal in the case of agricultural commodity?
I think you just plant trees.
Plant trees, yeah?
Well, in that case, that would mean that if, for example, they improve the agricultural practices, they could get the benefit for it, because they can then capture the value of reducing the emission while insetting, basically.
Yeah, yeah. There are actually a lot of methodologies out there on the voluntary carbon market for only farm carbon removal, right? So the way they work is indeed, so there's a farmer that is planting or growing something, and they look only at this. So the sequestration of more carbon in the soil, and you use the soil of the farm as a carbon sink, right? And you can do it by switching to regenerative practices. Obviously, one way to improve this is also to reduce what we do here. So both are very connected. But indeed, if you have positive emissions for growing the corn, then you can kind of compensate them with more carbon that will be sequestered in the soil. In certain cases, you can add them. In certain cases, you cannot. And so, yeah, so basically, right, so we have this, the upper part and the bottom part. And things that work in the regenerative agriculture is remove soil disturbance. So you start breaking the carbon chain in the soil. Crop rotation, having the soil covered, like cover crops between 2 seasons of corn or soy. You put cover crops in the intermediate season so that it gives more structure in the soil. You integrate livestock with grazing. Yeah, so that's a view of a field that is tilled and a field that is not tilled. And again, so here you have the greenhouse gas emissions from the crop, In that case, you will have it expressed per bushel or per megajoule. That's the energy unit. And then you have the carbon sequestration, so you can subtract the benefits from it. There are certain markets that tells you we don't recognize that, so then the CI score of your fuel will be only this. In that case, what about that? Then you can sell it on the voluntary carbon market separately, right? And obviously you need to make sure you're not double counted. So the biggest input or the biggest impact on carbon intensity score, these are yield, energy, and fertilizer. I mean, right now, 90% of carbon intensity score of agricultural commodities is fertilizer and energy use. Right? So it's then we look at many other things, but this is really where we can try to cut down emissions. Yeah, okay, and maybe that question, I have maybe two more, and then we wrap up. How exactly do you think about collecting data? Because I think this is the core about the MRV, right? Now we talked about data, we talked about regenerative practice, so how do you go about that? What would come to your mind? Do you go on the field and ask people?
So actually the degenerative practices of mass agriculture also might have had a positive side effect that we could use this, I don't know how it is called, but this hyper quantified agriculture, like
where they track everything
Yeah,
that's happening,
exactly.
like automated fertilizer management.
and that is definitely in commodity, or is commodifying, meaning
Yeah.
that could become more and more affordable also for small scale farming.
Yeah. Yes?
Yeah, ideally there would be soil sensors that can actually track these things, but there aren't yet any good ones on the market. I think. At least not multi-dimensional. They track usually humidity. I think that's at best what you can get, but but not in terms of biodiversity or something. You don't have that kind of sensors. So I think what is done too is that farmers can, like you have portals or platforms where farmers can upload pictures of their farming styles. I think that is something which is done, but then how do you verify that they haven't like photographed their neighbors' fields, right? Like so I think that there are many unsolved problems about monitoring.
This is used, no? This is like a citizen science.
Yes,
You use the satellite images and then you just verify local pictures. So you say people just submit it online. This type of data collectors already exist.
Yeah, I mean it's partly used,
If you could match like inputs paid, for instance, online with a specific farm, you could maybe like track down how much fertilizer or how much energy was bought by a specific farmer.
Yeah. So, I mean, I don't have a perfect answer, but what I want to say is that it's extremely complicated if you want to do it accurately. And I think Luis presented a graph where you see the more precise you want to be, the more expensive maybe it will be at the end, right? So you need to always keep that balance in mind. And I think there are always ways you can look at scaling it and reducing costs, but it's a hell of a work because growers typically, that's new in the US, but they use a lot of different farming softwares to manage, planning the operation, the crops, the fertilizer. It's all different scattered data. So you need to build data pipelines and APIs in every direction, and then reconcile all of that. So yeah, that's the first point I mentioned. Sensor data, even if you put sensor on a farm equipment, it's not as clean as you would like. There's a wrong calibration, the wrong setup, or the grower forgot to turn on the sensor, right? Sometimes that happens like this. Or they use only in partial operations. So I did 8 operations with sensor, but 2 without sensor. What do you do about the remaining 2? You just guess how much was the 2 left ones? Operations can be performed by third parties. In certain cases, you still see planes that spray fertilizer on the field, which sounds really horrible, but in that case, it's not in the same data report. And how can you trust or verify the data? As a last question,
you connect to multiple endpoint or API and you set up a pool for each source of data, gathering the data, and you have like validator, like a blockchain with proof of stake network, and you can just upload them into any decentralized storage solution, or stuff like that.
I like the way you say we just could.
I am working on that, so it's not.
But yeah, okay. Yeah, so I mean, just a few hints here, and I think that we really need to move on. But you can do algorithmic detection models that identify if you have a population of growers, one is underreporting compared to the other. Maybe there's something wrong, right? So it's where you can introduce some AI and ML models to try to optimize. Obviously, if it's incomplete, we can still look at default values. So we don't take your data because it's too poor. We take another default values. We can look at invoices, inventory reports, ERP data to back up whatever we track. We can use on-site soil sampling or soil centers, as it was suggested, satellite imageries, and then that's something we're investigating is actually giving confidence score to every data point or score of every field. Just want to say something about satellite imagery. Yes, there's a lot of companies out there trying to propose scripts and models, especially for regenerative agriculture. And they look at things like crop detection, crop rotation detection, tillage recognition, so you can literally see from the sky if the field was deeply tilled or not. And also recognition of cover crops. So you have things like vegetation index, which looks at the colors or spectrometry. And basically here you recognize that there's a certain vegetation. And some carbon programs or satellite specialist startups, they use that as a proxy for carbon quantification itself. So they can sell you a carbon credit which comes only from the estimation of that fertility index of the plants. But yeah, I think these are all beautiful things and we have a lot of work to make MRV work really for farming and fuel, and I hope it maybe helped you also have more angles of thinking about challenges in that space. Thank you.